And thanks also to Leonardo for the opportunity here to present this webinar series in relation to MICAT. My name is Wolfgang Eichhammer. I'm with Front of ISI in Karlsruhe, Germany, and this talk will be given together with my colleague Alessia De Vita from E3M. This is the first webinar in a series linked here to MICAT asset, and MICAT is about multiple impacts related to energy efficiency. And when it comes to the expression multiple benefits, multiple impacts, co-benefits, ancillary benefits, non-energy benefits, there have been a number of expressions used to express the idea that there is something beyond pure energy efficiency savings or linked in addition to energy efficiency savings. And on the right hand side, you see here a famous flower from the International Energy Agency, which was published, I think, nearly 10 years ago, which is listing a number of additional benefits linked to energy efficiency, like macroeconomic impacts, poverty alleviation, and so on. In our project, we have preferred to use the more neutral term multiple impacts in order to also allow for the possibility that there can also be negative impacts associated even with energy efficiency, but naturally the hope is that overall the impacts will be beneficial, and this is provides additional arguments to implement energy efficiency measures. But in practice, these additional benefits are rarely analyzed and in particular rarely reported in a very broad manner. Sometimes there are analyses done, for example, what are additional labor, additional employment, which is linked to some technology evolution. Sometimes some impacts on GDP, for example, but it's rarely reported in a broad manner, even in impact assessments. It's not done. One reason is that it's relatively complicated to report about the multiple benefits, multiple impacts, and requires frequently quite a number of models, detailed analysis to do so, which is not easily done. Now, in Europe, we are currently working very heavily on our different policy frames for energy efficiency, and notably the Energy Efficiency Directive, EED. And one important change that has been introduced in the Energy Efficiency Directive is the Article 3, which is pointing to the energy efficiency first principle. This principle shows or stipulates in a manner that wherever it is reasonably possible, energy efficiency should have a priority compared to supply options in a way. And this is the reason why also the directive advocates that member states should also introduce cost-benefit assessments and methodologies which allow a proper assessment of wider benefits of energy efficiency solutions, in particular from the societal perspective. And this was also a major drive to go forward with the development of a tool which can tackle the multiple impacts in a broad manner and in a relatively easily accessible manner in order to allow good and well-founded impact assessments at different levels. Let me further give you a justification for the multiple impacts, multiple benefits. This is a complicated graph, but this graph is, I will guide you through it. This graph was taken from another European project called NF First, so Energy Efficiency First principle. And as I said, the energy efficiency first principle tries to make a kind of trade-off between demand reduction and necessary supply. For example, in the residential buildings, it could make sense to more reduce the energy demand in order to use less, possibly district heating networks, decarbonized district heating networks, or less heat pumps, less hydrogen if it's relevant for the sector. And the question which we were asking ourselves in this project was, when we look at the energy system costs, is it cheaper to enhance demand, to reduce demand in a stronger manner, or to go for supply? And what you see here between the left-hand side and the right-hand side are two scenarios. The left-hand side are the energy system costs, which are related to a relatively low efficiency scenario, and on the right-hand side, a high efficiency scenario, so more demand reductions. And when you look to the costs, the system costs that are here accumulated in the period up to 2050, you see that there are some 130 billion euro accumulated over the next 30 years of difference between a low efficiency and high efficiency scenario. So conclusion from this approach is that the high efficiency scenario is a little bit more expensive than the low efficiency scenario, not much more, but it is a little bit expensive. That means there is not really a clear advantage or even a slight disadvantage when it comes to supply options. And you see here from left-hand side to right-hand side, why this is. You see in the second column the high costs of the building refurbishment that is increasing the cost the system cost quite considerably. And then we have a number of savings which are linked to savings on infrastructures, for example, district heating, electricity grids, and so on, which reduce the cost, but still we come up with slightly higher costs in the case of high efficiency scenario than compared to supply options as considered here. Now, I don't go into details here with the scenarios. There are a number of assumptions behind that you can discuss about these assumptions. But essentially, in order to argue for an energy efficiency first principle, you may need additional considerations, additional benefits to take into account. And this is where the multiple benefits, the multiple impacts come into the game. I mean, here the energy system costs do not take into account, for example, if we use renewables to generate electricity, the area that we are using. It does not take into account raw materials which are necessary to build up the supply technologies and so on. In the past or until the present, there were additional benefits when it came to the comparison with fossil fuels. In particular, we had strong air pollution linked to fossil fuels, electricity generation or district heating generation, which were quite important additional arguments, and there have been quantification of these impacts from fossil fuels. But in future, we are more and more comparing climate neutral pathways. So we will compare pathways with more energy efficiency and pathways, for example, with more renewables. So we would compare already options which are climate neutral and which have little local emissions, for example, in itself. And then it gets tougher, I would say, to argue for energy efficiency first. And for that reason, one has to bring forward things like possibly reduction in energy poverty, for example, reduction in area use, other impacts, reduction of other impacts of the environment, and so on. And this graph then shows how important, in order to really make the case of energy efficiency first, it is to have this broader view as compared to the pure energy system cost perspective. So this is a justification why to move forward with a structured approach linked to multiple benefits. And this was the reason why we have set up the MICAT project, the multiple impacts calculation tool project, which builds on previous projects run by Wuppertal, the Combi project, and the Odyssey Muir projects, which also developed an indicator-based approach to multiple impacts. And this indicator-based approach, combined with the features from Combi, the projections that can be set as the basis for the multiple impacts, this combination was the basis for the MICAT approach. And so here the aim is to facilitate the assessment of multiple impacts at European level, at national level, but also at local level. And we look on one hand at the quantification of such indicators, but also monetization of indicators as far as possible. Why aiming for an indicator-based approach? The reason is that we need sufficiently simple tools that can be used in quite a broad context, that can be easily implemented also on a yearly basis in order to have a good monitoring, and that also can allow for a reasonably well-defined methodology. Naturally, an indicator-based approach has limitations. It's less exact than, for example, a full-fledged modeling approach. Let me point, for example, to local emissions in case there is a comparison with fossil fuels that emit SO2 or NOx and so on. And those emissions may have a very strong geographically localized component, which cannot be reflected in such a more global approach, average approach in a country. So in such cases, you still need to go to a more detailed level in order to answer such geographically resolved questions. But the aim is really to have a broad look at a country as a whole, or at an entity as a whole, like a municipal area. Now, this shows the conceptual approach, and I already mentioned that we have different governance level which we are aiming for. We aim at the European Union as a whole. We aim at the national level, and have been looking at, in particular, at 3 case studies in Germany, Poland, and Italy. And we also have engaged with 3 cities in Europe, which are 2 of which are in Spain, and 1 is in Estonia. And we have also tested together with local actors the usability of the concept. And the idea here was to develop first the conceptual framework, how to evaluate those indicators, and then start to use the framework for impact assessment, either linked to scenarios and policy packages, or to individual policies. Important is the starting point of the indicators. We start typically for a different multiple impact indicators from energy savings. Some other parameters are also taken naturally into account, which then allow to establish the multiple impacts, to quantify them, and then with additional steps to monetize them. This shows the heart of the indicator approach. As said, it's not a full-fledged model-based approach. It's an indicator-based approach, and between the input data, which are in particular the energy savings and also some other input parameters, there are a number of impact factors or functional relationships which allow to translate the input data to the quantified impacts related to the different impact indicators. So that is the first important step, and we do that for a larger number of indicators which are grouped into 3 fields. I will briefly show you in the following, and which will be explained much more in detail in the following webinars. Once these impacts or functional relationships have allowed to quantify the individual multiple impacts, then there is the methodology which then monetizes the impacts, and which in a way allows also finally some aggregation, at least as far as quantization is feasible for the different indicators. And as already mentioned, the tool can either be adapted or set up on scenarios. So we call this a top-down approach, or on individual policies or policy packages, which we call bottom-up approach. Here you see the different configuration, how the MICATool can be applied. As that top-down, starting from scenarios, and this is naturally directed towards the future. When you come to the lower half of the circle here, when we go to individual measures or measure packages, the bottom-up approach, here you can have ex post view, so a view back to existing measures and what their impacts were, and also in the projections together with scenario analysis and the disaggregation by measures, you can also look ex ante to the multiple impacts. And the tool is constructed in such a manner that it can cope with different scenarios, which can feed the tool and then allow to establish the impacts here. And this is what we call the MICAT machinery. Also, the aim of what we are doing here is really directed in a practical implementation. So we have had a number of stakeholder interactions at different governance levels, at European level, at the national levels. We did a number of webinars or visits in the 3 countries I mentioned. And also we did a number of interactions with the local level. The target was here on one hand to establish the inputs, to validate data from those case studies, also to find out about the requirements of the stakeholders, of the policymakers, what are important aspects to report. For example, in a number of cases, energy poverty, alleviation of energy poverty was mentioned as an important point. Interestingly, the supply security came in at a late level after Ukraine events, but you can imagine from today's perspective, supply security is an important benefit of energy efficiency. Also, we started to make stakeholders familiar with the tool and the approaches, and the aim is really, as far as possible, at the end of the project, that this tool will be implemented, used at the different levels. We used it already, for example, in the frame of the impact assessment of the Energy Efficiency Directive I mentioned earlier. Last year, the tool was not yet fully operational. We have been working for the European Commission on different aspects, and notably the energy poverty alleviation was an important part which we worked for in the frame of this work for the Commission. Very quickly to show you the groups and some insight in the indicators, but this will be detailed much more in the following webinars. The multiple benefits, multiple impacts are divided into three major groups: environmental impacts, economic impacts, and social impacts. And you see on the right-hand side some indication how each of the group is broken down. You see the social impacts include, for example, things like alleviation of energy poverty, improvement of living comfort, and so on. Or you see here the different environmental impact in green or in red or orange, yellow colors, a number of broader economic impacts, including import dependency. In the three following webinars, we will dive deeper into these three elements here. Just to give you a short insight into one of these groups, into the economic groups, my colleague Alessia will take over here and very briefly introduce to you issues related to the benefits of energy efficiency when it comes to impacts on GDP, on employment, so that you would get a short insight into that. But as said, this is just to give you a very small insight, and in the following three webinars, you will dive deeper into each of the three areas. So you will learn more about the mechanisms which are the functional relationships which are behind the different indicators. There are also fact sheets which are behind this, which describe the methodologies, the methodological limitations, and so on. Because this is a learning process. We work on the empirical basis, we work on the relationships, and there are limitations to these functional relationships. But in future, once this tool is more broadly used, there will be possibilities also to improve on the empirical basis, to improve also on the implementation of functional relationships, and so on. Alessia, with that, I would like to hand over to you to give some brief insight into this economic part of the impacts here.
Thank you, Wolfgang. So basically, obviously, when one does energy efficiency, the obvious, let's say, things are like savings, obviously, in energy, savings in the fuel purchasing expenditures for the users, for the end users. But one of the big questions which policymakers obviously often have, but what is the bigger picture? Do I have benefits which I can sell, let's say, to my voters or whatever, in terms of the broader interest in what it means for the entire economy? So what we have been trying here is to simplify, because as Wolfgang was saying, this a simplified indicator methodology will never be able to replace complex models, but it is very important to have at least a rough idea when one suggests new energy efficiency policies, to have at least a rough idea of what these elements can mean. So what we have been trying to include in the indicators, and indeed, as Wolfgang mentioned, there are many challenges when trying to simplify things as much as possible, but they do give an idea of what it all means. What are the impacts of the energy efficiency measures on the GDP? What kind of sectoral shifts between sectors can be expected because of the energy efficiency measures when we install particular technologies or are expecting to install particular technologies? What will this mean for the different sectors? And therefore, what it will mean for the different employments. So what kind of skill sets will be needed, and will we have benefits in terms of employment in the different countries and areas? And obviously, will there also be competitiveness gains for the economy overall compared to international competition and between the sectors as well? So what we have tried to do is to make it obviously for this purpose as simple as possible, using static Leontief multipliers. This we will talk about, as Wolfgang mentioned, in the next seminars. Trying to minimize also the number, and this is in general, not only for the economic impacts that we have tried to do, to minimize the amounts of end user inputs which are required for the tools in order to allow the tool to be used by as broad an audience as possible. And therefore, what we have tried to do is that you take the energy efficiency measures, so the savings which will be taking place because of the energy efficiency, to try and understand what that would mean in terms of sectoral investments. And then obviously for each of the specific indicators or topics that need to be addressed, there are specific multipliers in order to understand what are the impacts on the specific indicator that we would like to analyze, and then in order then to have the full economic impact. So finally, what one gets is the first estimates of the economic impacts, and the first steps towards understanding what are the economic co-benefits of the energy efficiency measures that we are implementing on the broader economic scale. And I think that's enough for a first introduction at this point, and the details will be in the next webinars, which will be taking place over the coming months. Yes, so Wolfgang, back to you.
Thanks a lot, Alicia, for these short insights here, just to get a little bit more flesh, a little more details. What is behind the approach, and as said in the following webinars, and here we are, you get more insights. We will have the next webinar focusing on the social indicators, like energy poverty, for example. That is in April, 6th of April, and I'm glad that our colleagues from Wuppertal Institute are looking into those. Following by this, the webinar in May, 4th of May, which Alessia already mentioned, which will be done between ISWM and Fraunhofer, also here, colleagues seen here on these photographs here. And then finally, the third group of multiple impacts, the environmental indicators, in June, beginning of June. This is done by a colleague from IASA. So with this, we will cover the three main fields. As said, there are fact sheets behind that will be available also on the website of MICAT. And finally, we also have the webinar 5, which in July is addressing the needs of the actors at the different governance levels. There are different colleagues here visible on the photos, and notably we also have ICLEI at the local level, who has engaged with us in the interactions with some actors there. And I think I also saw some participants here, for example, from Victoria-Gasteiz. That is one of the cities who has been participating in these exercises. And we think these needs of the actors is also very important to consider, because really this multiple impact approach is one that is really broadly to be used in future, in particular with respect to energy efficiency first evaluations. Now, coming to the end of our presentation, I'm aware that this was only the start here, and we only scratched a bit at the surfaces of the contents here, and we hope you will be able to see more. But let me summarize very quickly the important points. So we think with this multiple impacts approach, we will serve the stakeholders to better characterize future climate neutrality pathways. Remember what I said at the beginning when I motivated MICAT and this talk. In future, possibly the trade-off will not be any more so strong between, let's say, renewables, energy efficiency on one hand, and the fossil fuels, where we had a number of benefits like improved air quality and so on that played a role. but in future it will increasingly be the task to distinguish between different climate neutrality pathways, which in itself have already benefits by reducing CO2 emissions, by possibly improving on local emissions, and so on. So different weights will be given to different multiple benefits, like, as I mentioned, the area uses and so on. This will be an important basis for the analysis of the energy efficiency first principle, which has got quite high on the agenda in the European Union. It is a simplified approach, which is necessary in order to allow really a broad use. It's based on indicators, it's linked to energy savings, and there are functional relationships which express the impacts. We work on the empirical foundation, so in a way, these relationships are gauged also with more refined modeling approaches, but naturally, indicator-based approaches have limitations when it comes to exact representation or evaluation of individual cases, in particular when it comes to geographical issues and so on. And the final aim of this approach is there will be a broad use in impact assessments, for example, in Europe at the national levels and at local levels. But we also hope with this webinar that this approach can be interesting also for other regions in the world where the assessment of multiple impacts is also quite rarely done, and having tools that allow for a systematic first analysis of the multiple impacts is certainly something which will benefit in a broader way across more countries than just in Europe. With that, I would like to thank you for the attention and close my presentation, and we can go over to the question and answer session. Thank you very much.